Negative exponents? Are you kidding me? I can barely do regular exponents, and now you're going to make them negative?
Today we are talking about negative exponents and 0 as an exponent. So I don't know if this is new to you or if some of you saw this last year or not, but let's go ahead and kind of have to study it and see for yourself what the pattern looks like. If I have 1 over 5 squared, and then his reciprocal, he moved back upstairs, not his reciprocal, but let's say I wanted 5 to not be in the denominator anymore. Then if he goes upstairs, now his exponent is negative. Likewise, if we look here, his exponent is negative. When he moves to the upstairs, it's positive. Okay, so this is a subtle thing, so I really want you to look at it closely, and then we're going to actually hopefully make more sense of it. We'll talk about the fancy definition of what it means to have x to the negative number. So you're used to seeing lately exponents that were positive, right? So to see a negative exponent, it just means that the base would rather be in another part of the fraction. Let's look at this. If x is any real number and n is any real number that is not 0, then 1 over x to the n is the same as x to the negative n. So when he goes upstairs, he becomes negative. Let's put this into practice. Let's take this. If I want to write 3, not in a fraction, I want 3 to come up and be in the numerator. I want the base to be in the numerator. I can do that. I just need to give the exponent a negative now. So those are equal. Those are equivalent things. 3 to the negative 4 means 1 over 3 to the positive 4. Okay. 7 to the negative 2 is equivalent to 7 going downstairs and getting a positive exponent. Okay, so this might be weird for a couple of you. This one, 5 to the negative 8, or 1 over 5 to the negative 8, can be a regular 5. Now the exponent changes and becomes the opposite. So when it goes to the numerator, the sign of the exponent switches. Now he's in the numerator. See how it switched when it went to the denominator? Went from negative to positive, went from negative to positive. So you can have negatives below. It just means when you go to the numerator, it becomes positive, or negative if it started out as a positive. 6 to the negative 3 would be 1 over 6 to the positive 3. And let's go ahead and try these. I want you to pause me and see if you can figure out what this one is before I say it, or I'll give you a second. 3 to the negative 2. And simplify, meaning we actually don't leave the exponent anymore. Meaning when we're done, you should just have a fraction with no exponents. Okay, so 3 to the negative 2 is the same as 1 over 3 to the positive 2. And 1 over 3 to the positive 2 is 1/9. Okay, so 3 to the negative 2 is 1/9. It goes downstairs and squares. All right, this one, pause me and see what you get. Let's give this a positive exponent and then figure out the answer. So to make this exponent positive, he needs to go upstairs because he was downstairs. And goes upstairs, now he's got a positive exponent. And then if we simplify that, that means 3 times 3 times 3, which is 9 times 3, 27. So when it says simplify this, we're looking for just a final answer. No more exponents. Oh, tricky one. Now, what this means is this whole thing goes downstairs and has a positive exponent. So this is what it looks like. So nothing changed there, and this changes. Went from negative, now it's positive. Now what that means is 1 over -3 times -3, which again is positive 9. So isn't that interesting? These would give us the same answer. Okay. Now we're going to switch and do something a little different. We are going to review the product rule. If m and n are real numbers and x does not equal 0, then when we multiply the same base, we add the exponents. Multiply same base, we add the exponents. That's what the rule was, and we've used that before. So remember, when we multiply the same base, we add exponents. So now we've got negative exponents. And in order to do this, I was thinking about, well, I'll probably leave it like this. I was thinking about switching this around so we could see what this really looks like. And maybe I will in a second, if we made all the exponents positive. Well, maybe I'll do that right now. Okay, this is equivalent. This is not what they're asking us to do, but I just want you to look at what this means. That means x to the 4th m squared. They don't move. They have positive exponents. These two have negative exponents. So what we could do is this. And I just wanted you to see that this is equivalent to this. These are the exact same value, because these were negative exponents. I was showing you where they go. Then this can be simplified this way, but let's do it using the product rule. So I just wanted you to see that. I'm going to cross it out just so it doesn't get in the way, so we don't mistakenly use that as when we're solving stuff. Okay, so again, when we multiply the same base, we're going to add the exponents. So I'm going to start with the x's. I have x to the 4th and x to the -2. So if we add those, 4 plus -2, we're going to get x to the 4 plus -2. So that is 2. 4 plus -2 is 2. And then we're going to do the same with the m's. We have m to the +2 and a -5. A +2 and a -5 is a -3. And that is this simplified. That's the answer that they're looking for. This is it simplified. X squared m to the -3. Now, if we wanted to write this with positive exponents only, an equivalent, sometimes the book will say, give the answer in using only positive exponents. Then what you would do is have x squared over m cubed. These are the same. So look at that. This is just kind of a little window into the future, because we're going to be doing this later. I just wanted to give you a taste. And sometimes they want us to write it with positive exponents, but this is the answer for now. Okay, same thing here. We find all the same bases and add their exponents. So let's start with x. Okay, x has a -2, a +4, and a 1. Don't forget this one has a invisible 1 there. So we've got -2 plus 4 plus 1. 4 plus 1 is 5, and a -2. We get cubed. And then could you pause me for a second, see if you can finish this on your own, and see if we match up the answers. So ready, go. Okay, so hopefully you've done this, and now you're going to see if we agree. So I see a y to the -6 and a y to the 5th is y to the -1. And then I've got a z to the 1, we can't see it, and z to the 5. So that's z to the 6. So that is the answer, hopefully, that you had. Now, I'm going to take it a step further. The book isn't asking us to do this, but I want you now to rewrite this all with positive exponents. Rewrite this expression using only positive exponents. Now, if you know what I'm saying, go ahead and pause and try it. If not, I guess you can watch and see what I do. All right, well, this is positive, so nothing changes there, and the z is already positive. So they're happy. this guy had a negative, so he would like to go to the denominator to become positive. Now that he's positive, though, a positive 1 does not need to be written. So if we were to write this with only positive exponents, the answer would look like this. This was extra. This was an extra exercise I wanted you to try. This is what the book was looking for. All right, sometimes we get something to the 0 power. And when something is to the 0 power, we want to say that the answer is 0, and that is a mistake. Let's look at what it means to have something to the 0 power. Let's take this. Let's take, just for example, if we put 6 squared over 6 squared, that's equivalent to 1. Same thing on top and bottom, 36 over 36. Now, let's write this using positive. Let's take this and let's put them side by side. That's the same as 6 to the positive 2. And then if this one goes up into the numerator, he becomes a negative exponent. So 6 to the positive 2 times 6 to the negative 2. I want you to write that. Right now I've written 3 equivalent expressions. So now let's use our product rule where we add the exponents with the same base. So we get 6 to the 0, because 2 minus 2 is 0. So when we have something to the 0 power, what does it ultimately equal? Well, it ultimately equals 1 whole. Anything to the 0 power equals 1, and here's just a little show of an example. So the fancy definition they like to use in boxes, if x is any real number that is not 0, then x to the 0 power, which means anything, x represents anything, to the 0 power equals 1. And there it is. Anything to the power of 0 equals 1. Anything. A million to the 0 power equals 1. You're going to be tempted to say something to the 0 power is 0. You're going to really be tempted to do that. This is counterintuitive. Unless we look back and see what does to y. And this is our y. And then we've got to just remember it, because you're going to sneak in there and you're going to want to change it and have it equal to 0. So let's try some of this. Simplify the following expressions. So this looks very close to what we did before, but I'm guaranteeing you that we're going to see x to the 0 power. There it is, or y to the 0 power. We'll see x to the positive 2, x to the negative 2. So I'm going to do this in 2 steps, just so you can see. That equals x to the 0 power, y cubed. Now, when you get something to the 0 power, you can now cross it out, and it equals 1. So our final answer is 1 times y cubed, which is just a y cubed, because we don't write that 1. Try letter B and see if we get the same answer. So go ahead and pause it and try. Okay, so I will start. They started with m's, so I'm going to do the m's to the 5th and to the 1st power. So we've got m to the 6th times b to the 0. B to the 0 can be replaced with a 1, so our final answer is m to the 6th. Okay, so hopefully we agree. All right, now we're going to use the distributive property. So this is going to be a little more busy. Let's just call it busy. We've got positives, we've got negatives, we've got lots of letters involved, but it's very similar to what we've done before. I'm peeking in the book to see if, yes, they're doing what I would first do, is I see to the 0 power here. So I'm going to cross that out. Anytime I see something to 0 power, I'm just going to put a 1 or just cross it out if it's multiplied with something. So now we really have x to the 5th z times p to the negative 3 minus 4x to the negative 5 z to the negative 1. Now we just do what we've done before. We're going to multiply x to the 5th z times p to the negative 3. So what we have is x to the 5th z p to the negative 3. That's what happens when those guys multiply together. Now we're going to say this was like a imaginary 1 or an invisible 1. So 1 times negative 4 is minus 4. And now we've got a positive 5 and a negative 5 for our x. So we get x to the 0. And now we've got z to the 1, z to the negative 1, which is also 0 to the 0. So you see where we're going with this. When we've got these zeros, we go, okay, I can get rid of that, I can get rid of that. So what do I have left? When all the dust settles, what's left is, I'll write it over here, x to the 5th z times p to the negative 3 minus 4. That's all that left. That's all that recovered from this. So there's lots of areas to make a mistake because of all these little numbers that you don't want to lose track of. Let's try it again. I want you to try this one, and then we'll compare when we're done. Okay, so when I first multiply this times this, I notice that the x's drop out and the y's drop out. We get x to the 0, I'll just write it. X to the 0, y to the 0 is what happens when we multiply the first. We multiply the second term with the one outside, we're going to have plus 4 x to the second, or x squared, y to the 0. So now I see all these x, y's, zeros, so the only thing that's going to end up, the answer is not 4x squared. You might have wanted to do that. Remember, these cancel out and become a 1. So we still have a 1 here, plus 4x squared. That is probably going to take a little while. There might be a learning curve on why we still have a placeholder here. This doesn't turn into 0, turns into 1. So be careful of that part. Now let's simplify all these things. Anything to the 0 power is 1. B is going to be a trick. So A, 2 to the 0 power is 1. Ooh, negative 2 to the 0 power. Now, is negative part of that? Here it is. See how they're written differently? In this case, the negative gets raised to the 0 power. In this case, it doesn't. So that actually turns into negative 1. 2 to the 0 power is 1, and there's a negative in front. This one, this means the whole thing is to the 0 power. The whole chunk is to the 0 power, so it equals 1. Now we've got practice. This is a really good chance for you to see if this is clicking with you or not. So please turn this off and then check. Don't just move on. Check and do this right away. And so turn it off and I will work these out myself. All right, so simplify. That equals 2 to the positive 3 because it goes upstairs. And 2 cubed is 8. Then this one, negative 4 to the negative 2 turns into this. 1 over negative 4 squared, which is 1/16. 8 to the 0 power equals 1. That was a nice one. This one, again, the negative is not in parentheses with the 0 there. So the actual answer is negative 1. This is going to be a tricky one, I think. If it's not, then I am very happy for you that you're getting that. F, this is raised to the 0 power, so the whole thing equals 1. Again, you might want to do something with this, but it's just this whole chunk in parentheses is raised to the 0 power, so it's just 1. So that's kind of nice. Okay, now we're going to go into the little numbers that we have to be careful of. Okay, so we're going to simplify this. So at the end, I know I'm going to have x, y, z all to a different power, probably. So I look at my x's. I've got negative 3, 4, a positive 2. So 6 and a minus 3, so x cubed. My y's, I have -8, 5, and that's it. So that would be y to the -3. Then we have z to the 1 and 5. So z to the 1 plus 5 is to the +6. Next one. I'm wondering if we're going to help. I see a 0. So we get x to the 8th, y to the -3, y to the +3 is y to the 0. Y to the 0 is just 1. And there we go. X to the 8th is that answer. Now we're going to do this longer one. Expand this. We're going to start with, we have a 2 because 2 and 1 multiply. Now we've got x to the -2, x to the +2, so that turns into a 0. I'm not even going to write that. And then, or x to the 0, which is 1. And then y cubed to the, and y to the 1 would be y to the 4th. That's what happens when I multiply those two terms. All we'll be left with is 2y to the 4th. Now when we multiply the other terms, we've got minus, now 2 times -3, minus 6. Okay, x to the, be sure we got this. -2 plus -1 is -3. And then we have y cubed, y -3, so those go away because they're equivalent to 1. And that would be our final answer. All right, this is new for some of you. Please call and say, hey, Mr. Shield, I'm having trouble, or email me if you can't quite figure out why things are happening when you're doing it, if you're not getting the same answer as me, if we're not matching up. But other than that, this is pretty fun because they always follow the same laws. They don't break the law. That's what I like about this stuff, is we don't have exceptions. They are following the rules as long as we get a good understanding of what those rules are. And that is it for lesson 29, and we will see you next time.